Okay, sounds good. All right, hi everyone. I am Frank from the status team. I am the DappConnect team lead, and today I'm going to talk about DappConnect and how you can use it to decentralize communications in your Dapp and web app. Let's go right in. So I have 4 points on my agenda. First, I'm going to talk about the Waku Protocol, and I present it. Then we talk about what is DappConnect. Then we look at some use cases that could benefit of DappConnect. And then finally, we look at some code to see how easy it is to use it. So let's get right in. So the Waku Protocol. The easier way to present the Waku Protocol is just to look at its inception. So when Web3 was created, there was 3 protocols. Whisper for communication, Swarm for storage, and then Ethereum for contracts, as you know it. So Status created the Status app, which is a decentralized messenger app, and tried to use Whisper at the time. Unfortunately, Whisper is not really mobile friendly. So for example, it uses proof of work for spam protection, and this doesn't really work when you have a mobile phone on one side of the network and maybe a server on the other side of the network. So we created Waku v1 or Waku mod, which is built on top of Whisper and modify some of the protocol or add some of the feature to be able to run Status on a mobile phone. And this is what the Status chat app is currently using. So Status chat app is a fully decentralized messaging app and it's using Waku v1. Now, having learned some lessons from using Whisper and Waku v1, we came up with Waku v2. And the idea here was to start with a brand new tech stack and starting fresh from all the lessons learned. So Whisper and Waku v1, for example, use Dev P2P, like Ethereum 1 for transaction and blocks, so the same technology, whereas Waku v2 uses Li P2P as a new tech stack. So that's how we get to Waku v2 from the need from building the Status chat app. So Waku v2 is a set of protocols, so it's a bit hard to summarize a goal in a short paragraph, but that's my best go at it. So Waku v2 goal is to provide you an infrastructure and standard for decentralized off-chain private communications to the Ethereum ecosystem while considering the limitations of restricted resource environment. So it's a bit of a mouthful, so let's break this down together. So infrastructure. Infrastructure is in the same way than when you build on Ethereum or when you use Ethereum, you don't need to have an infrastructure, you don't need to run your own Ethereum node. So the idea with Waku is that you can build on Waku, you can use Waku, but you don't have to run your own node. However, Waku is an open system. All the code is open source. All the specs are open source Creative Commons, so you can run your own node if you want, but you don't have to. You don't have to run your own node to use Waku. You don't have to run your own node to build your Dapp using Waku. Standard in the way of the Web3 API, similarly, a de facto standard, a common ground for everyone to build and add communication to their system. So whether you are jumping from one project to the other, or maybe you want some interoperability between your Dapp and the wallet, having Waku as a common standard allows this interoperability to happen and just make it easier to build faster and add decentralized communication to your project. So decentralized is, so I think you are all familiar with what decentralized means. So it's a technical property that gives you a lot of functional features and benefits. So Waku is a decentralized network. So you have same benefits than for Ethereum. It is so it's a censorship resistant. You don't have a single point of failure or bottleneck. You can run your own node. You can connect to any node, and you don't have the risk of ending up being censored or anything like that. So Waku is a decentralized network. I mentioned off-chain just to be sure that everyone understands that the idea is not to use the Ethereum blockchain to send messages and pay gas every time. So the Waku network is a separate network from Ethereum. So it is off-chain in the way that you don't have to interact with the blockchain and you don't have to pay gas. However, as I mentioned, it is a set of protocols. So some of the protocols, for example, one of the spam protection protocol we're working on uses a smart contract on the blockchain to help with this spam protection. Because Waku is very modular, it will really be up to the developer to decide what protocols they want to use and which one fits best their usage. Private, so we are aware that some dApps want to have some privacy guarantees, whether it is pseudonymity or maybe end-to-end encryption. So Waku gives you these basic building blocks to make it easy for developers to, on one hand, add these features, add encryption, but on the other hand, also knows that their message, that it's hard to find the originator of the message, for example, and things like that. So the specs, from the spec point of view, we are trying to ensure that we are keeping some privacy guarantees at all time. Plus, there is a possibility to use the protocol in some ways where you can increase these privacy guarantees. Communication. So Waku is about communication, which is basically sending and receiving messages. So it's not a decentralized storage solution. It's purely about communication, being able to have this near instant communication happening, and more about, I would say, ephemeral messages in the way that it's not about storing data like IPFS would be. So it's really a communication protocol. So Ethereum ecosystem. So Status is an Ethereum app. We are an Ethereum company, and we are building Waku to make it easier for DApp developers Ethereum DApp developers to use Waku. And we are looking at providing examples and easy ways to integrate Waku with Web3 API, for example, when it makes sense. However, it is an open system, so anyone that wants to use Waku can use it. There is no restriction, no one stopping it. We are aware of some blockchain projects that are interested in using Waku and which are not Ethereum related, for example. And finally, you don't have to have a blockchain project to use Waku either. So it is a decentralized communication platform. So anyone that has a need for that could use it. And finally, so I already talked about how Waku V2 was created from the need of running status app on mobile phone. And that is something that we are keeping in mind. So by restricted resources, we are talking about having limited CPU, or maybe limited bandwidth, limited connectivity, so not being online all the time. But we're also talking about browser environment. So in a browser environment, you may have the data, but maybe you don't have access to the TCP stack, for example, and you have to use WebSockets. So we are aware of that, and we're providing an array of protocols that allow people to develop their DApp, whether it's natively on mobile phone or within a browser. You will have a protocol that you can use in the Waku, from the Waku protocol family. All right, so far I've been talking about very abstract concepts. So what do we have concretely today? So we have a few implementations. We have NimWaku. So NimWaku is the reference implementation. It is an adaptive node in the way that you can start your node and you can select which protocol you want to run. It can be either be used as a backend for a more complex system. For example, this is the node that Wallet Connect 2 uses. You can use it as a native library as well if you may be running, creating a desktop app, or you can just run it as a node, as an incentivized node. So part of the drawback of Whisper is there was no incentivization in running the node, and that's something that we're currently working on for Waku. Then we have the JavaScript TypeScript library, which is targeted for dApps, web apps, and wallet. I will talk more about it in the next section. And then finally, worth mentioning, we do have a Go implementation that is used as a backend for the status chat app on mobile and desktop. So at the moment, the status chat app still uses Waku V1, but we're actively working to migrate it to Waku V2. All right, so why would you want to use Waku for your DApp? So Waku is here to solve communication. So whether you want to do a user-to-user communication, maybe a chat app, maybe having a troll box in your Exchange or in your Dex or something like that, you could also do operator-to-user communication. For example, if you run a DAO and you want to notify your users or your token holders that a vote has started. Any kind of communication you want to do, you have two ways to do it. Either you can go for a centralized way, and then run a server that handles communication for you, but then your DApp becomes centralized. Or if you go in the decentralized path, then it's not easy. And so the idea is that Waku is built with the research team, and we are tackling these hard problems. And then it's really up to you to either just use it or join the effort. And same way that by using Ethereum, you don't have to solve the scalability problem yourself as a DApp developer, but you can get involved in it. So the same way here, we're trying to solve all the hard problem of having decentralized communication, working with mobile devices and browser, and you can either use it or you can even join the effort if you are, on the research side of things. Finally, the idea is really to have an out-of-box solution. So Waku, it's a very complex layer of protocols, and the idea with DappConnect is to give you a very easy gateway to the Waku network. All right, jumping in DappConnect. So Waku is really the protocol, and I'm trying to use the Waku terminology for everything that is protocol related. DappConnect is more the entry point for Dapp developers. So the idea is that as a Dapp developer, we should be able to just search DappConnect and find it and jump right into it. So what we want to have with DappConnect is a set of documentations and libraries that allows you to add decentralized communication to your dApps, web apps, and wallets. So we have the JavaScript TypeScript library, which is JSWaku. We do have some code examples and working on some tutorials, explanation videos like this talk, and use case studies extra. So the idea is to really have like a full, an easy way to add Waku to your DApp, and that's what we call DappConnect. So let's look at what's available with DappConnect. So today we have JSWaku. It allows you to receive messages. So we have here, I mentioned two protocols. So we have the Relay protocol. So the Relay protocol is your gossip sub peer-to-peer protocol. So you are connected to peers, which are your neighbors, and they receive a message, and then they forward you the message. So this works well when you have connectivity, when you have a healthy number, you are connected to a healthy number of peers, and you receive message live, and then once you receive message, you just forward it, and it's done. This doesn't work if you don't have signal. Okay, you're on your mobile phone, there is no connectivity, and when you resume connectivity, these messages are lost. So what we have the store protocol. So we incentivize people to run their own Waku node using NimWaku, activating the store protocol, which will store and save messages as they encounter on Relay. And then from a mobile phone, you can query the store node and ask for any messages that the store node has seen in the last 10 minutes so that you don't miss your messages. So that's a kind of situation or kind of features that Waku provides to allow you to be able to run your DApp and have communication even if you're on a mobile phone. So same thing for sending messages. So you can either send your messages over Relay, which is you pass the messages to your neighboring peers. But if maybe you don't have good connectivity, maybe again, you don't have a healthy number of peers and you want to be sure the message is sent, then you can use the light push protocol. And so the light push protocol, again, the nodes that support light push will most likely be, run NimWaku nodes running in the cloud. And so you can contact this node, send a message, and this node will confirm that they receive a message, and then they can broadcast the message over Relay for you. So again, situation where you don't have great bandwidth, you don't have great maybe data limitations, then you can use light push instead of Relay. We have encryption, asymmetric available, and signature. So be able to encrypt your payload or sign your payload. And this is done very easily, and we show you in the code section how it's done. We also have a couple of code examples, so very naive little web apps that can demonstrate how you use the library and how it works. We have a web chat, which is just a chat room. And we have an end-to-end encrypted direct message where you can send a message to someone only knowing their Ethereum address. So Alice wants to send a message to Bob. Alice only knows Bob's Ethereum address. And if Bob is keen to participate to that, then he can receive encrypted messages from Alice. So it's very naive, easy protocol, but that's good ways to demonstrate how things work. And finally, our API and documentation, our API code is also documented. That's what we have ready today. So what's next? So I've been working on Waku just this year. So there's on GS Waku just this year. So there's quite a number of things to be done. And I'm hiring. So at the moment, it's just me in the team. So if you are a developer and you are keen to this project excites you, then please feel free to check out the job opportunity status. So at the moment, we're working on the website as well. So I have a nice DappConnect website where I can list more tutorials and use cases to really showcase what you can do with Waku and help any Dapp developer on board. I want to work on more code examples. I'm very excited to do some state channel code examples. I will talk a bit more about that just after. GS Waku stability. So we actually have a couple of dApps as status that are going to use GS Waku. So just need to fix some bugs. And I'm trying to have a very open process. So the code is open source, the specs are Creative Commons, and I have a project board as well so that you can check out the priorities there. So right, use cases. So so decentralized communication. So why do we want that? What's the point? Okay, we have the chat example, but is there any other use cases that we could use? So literally anything off-chain. So when you go off-chain, what do? You usually want to take some of the messages or transactions that you do on the Ethereum blockchain that we have to pay for. I'm trying to not have that on the blockchain and instead doing off-chain, right? Doing directly between peers, maybe directly between a participant and an aggregator if it's a roll-up. So anything that needs a communication layer and moving off-chain could use Waku. So if you dig a bit more, so we already talk a lot about chat app examples. So status chat app allows to have private groups which are end-to-end encrypted. There are public groups and private peer-to-peer messages. So we talked about that already. Okay, Ethereum scalability solutions. So if you want to do, so when you create state channel, so you would usually lock some asset in multisig on the blockchain between a number of participants. And then these participants can exchange signed messages, signed transactions with each other. At some point after 10, 100,000 messages, you can decide to go on the blockchain to update the state of this multisig. So today, if you want to do that, then you do have to solve the communication problem. How are these participants going to connect to each other? How are they going to send messages to each other? And that's one part of the problematic of doing such peer-to-peer system. Using Waku, you can easily have the communication done and sorted, and just focus on your state channel logic. Same thing for rollups. So in rollups, so same thing. You lock some assets on the blockchain, and then participants will send transaction, like rollup transaction to the aggregator. At some point, the aggregator will take transaction and push some proof on the blockchain. So again, you have to have some off-chain communication here. Participant needs to send this transaction to the aggregator, which means that the aggregator may need to publish their IP address and port to be, to receive these transactions, and then cause the risk of, of being either blocked or being taken down or anything like that. So using the Waku network, then even if you just use one aggregator, you could just use the Waku network to send the transaction over Waku, and the aggregator doesn't have to expose itself. Instead, just use on the Waku network. I still need to do more research on this topic to really have a nice refined use case. It will also be interesting to look at cases where several aggregators listen on the Waku network and see if we can have some kind of market there. Voting. So voting, we do have, so we have a status. We are currently working on the status community directory creation DApp. So in short is being able to have a list of curated communities available on the blockchain. And so for these communities to be voted in, we need to do a vote. And so it's a blockchain vote. And so what we are looking into is, what we are working on is to have a more gas efficient voting. So instead of a community owner opens the vote to get their community in the directory, and then everyone has to vote on the blockchain and pay fees. Instead, the owner opens on the blockchain, but then participants, voters, can just vote over Waku. And once everyone has voted, then someone can grab all the votes and submit them to the blockchain. Or several people can do that. If maybe there is someone who's keen to put the yes vote in there, someone is keen to put the no vote in there. So, which means that as a voter, I don't have to pay gas, but those who are more keen to get the vote resolved are the one who pays gas. So that's one way to have voting happening without having everyone to pay gas, basically. Another one is a gasless poll. So again, related to this DApp. So what we want to have is some featured communities. And so this is fully done over Waku. So as a user, you can vote for a community. So as a token holder, you can vote for a community to be featured. And so each DApp, so each mobile phone, each user will collect the votes for the featured community and then display the local result. So here there is absolutely no blockchain interaction, and that's one way to have a decentralized poll happening without having to pay any gas. And so each client will just look at the vote they can see and display the feature community for the week. And so these two projects are being currently worked on. And finally, so again, any kind of communication you may need for your dApps then could use Waku without having to solve the hard problems of decentralized communications. One subject I quite like is NFT auctions. So if you look at some of the NFT platforms today, a number of them are centralized. So in the way that when your NFT are centralized on this platform, so they custody your NFT. And when you start an auction, it is off-chain, but it's off-chain within this centralized platform. So you start an auction, and then people can bid, and then at the end it gets transferred from one user of the platform to another user of the platform. And that, of course, we all know what risk it brings to have such custodial solutions. So with Waku, you could have again a system like that where the NFT owner could start an auction on the blockchain, and then the bid could be transferred via Waku. At the end, the bid could be taken by the owner, the highest bid could be taken by the owner and pushed to the blockchain. Again, I have to do more research there, but that's the idea. So really trying to limit the gas cost there. Of course, all of that could still be coupled with any rollups. You can still use optimistic rollup to do all this, the fewer blockchain actions that you need to do, but you still save gas because you limit the number of actions you have to do on the blockchain at the end or on the rollup. So Wallet Connect 2, so I know that talk has been already done for Wallet Connect 2, and they mentioned Waku, so they're using it, and here's the idea is again decentralized communications. Instead of having DApp and Wallet Connect to Wallet Connect servers for communication, they're all done via the Waku network, and the Wallet Connect server can just listen to the Waku network instead of receiving directly the connections from the different users. All right, so use case is done. Let's look at some code. So just wanted to show how simple it is, and we're trying to have a very simple API. So to get started, just use the JS Waku package, JavaScript package, and you can just do Waku create and create your node. So trying to have very good default so that you don't have to pass any option parameters. And there is the option to do that as well. If you do want to pass option parameters, you can, but the idea is that it's simple and just work out of the box. So once you have your Waku node, you can listen to messages. So just wanted to mention the content topic. I think it's a good way to get an idea of how things work. So when you create a DApp, you decide on the content topic. So I created my DApp, and you may have some features that use the Waku network. Maybe you have one feature for group messages and one feature for direct messages, for example. So you can just put that into content topic. And now when I want to listen to messages, I just need to add an observer and just say, I just want messages from this content topic. And that allows your client to not be flooded by all messages from the network, but just focus on the messages that are relevant to the DApp. And then you have a message and you can process your message and do whatever you want with it. All right, and send messages. So, so if you look at the first section here, it's just a very easy way to create a message. Again, you pass a content topic there so that your message is categorized basically, and on the other side, only the only user of your DApp will process process these messages. Once you have your message, you can either use Waku relay, so very composable design here, waku.relay.send, and you send it to your neighboring peer that can forward it. If maybe you have poor connectivity, as I mentioned before, or you want to be sure you have confirmation, then you can use light push. And in this case, you push a message to one of the light push node. So again, here, one of the ideas is to make it as easy as possible for you. So in this case, it will select a light push node that is connected to, in the way that you don't have to find node for you. As part of the discovery, we try to find a light push node and select it and send a message to this node. And this gives you an ACK, so acknowledgement, and then you can do some processing if you don't get the acknowledgement. So I also mentioned before the store protocol. So store protocol allows you to do direct query to a node to get messages that you may have missed. So again, Waku.store, and then you query the history, and you pass the content topics you are interested into, and then you get the messages back. So very simple, succinct API, and so that's how you can then. So you play with relay and store. Maybe if you resume connectivity, you are going to use the store. Or if you connect to a new store node, then you're going to use store just to see if there is any messages you may have missed. And that's the idea. It's just composing the protocol together to be able to achieve your goals. And so I also mentioned signing and encrypting messages. So if we have a quick look here, so the idea is that the API provides you a way to generate private keys, or you can generate private key in your waves, maybe related to your DApp. And then when you create your Waku message, then you have a set of options where you can select, pass a recipient public key and pass your signing private key. And so Waku will handle signing and encrypting messages for you. So it means that if you want to do end-to-end encryption, you don't have to do much. Okay, you just have to generate the key and that's it. You don't have to worry too much about the cryptography. Of course, again, it is all open source and it's all specs, so you're free to have a look and see what it is. As I mentioned before, we are targeting the Ethereum ecosystem. So, for example, in terms of choices for the cryptographic schemes, there are choices we chose schemes that are very commonly used in Whisper and Ethereum. So that it's nothing brand new, it's nothing odd. It's something that really fits with your, in the Ethereum ecosystem. And then once you have a message, you can send it via relay or via store via relay or via light push, as we previously discussed. Okay, and same thing. So when you want to decrypt messages, so if you're expecting encrypted messages, then you can just add a decryption key to your Waku relay. So again, just trying to make it very easy for you to add these features, privacy-oriented features in a very simple manner. And then you can pass, you can use private keys for private public, so asymmetric encryption, or you can pass a symmetric key if you want to use symmetric encryption. And then Waku will just try to, so your node will just try to decrypt the messages. And when you use your ad observer, you just get the decrypted messages, and you don't have to handle the decryption yourself. All right, so so I'm done. Went 2 minutes faster than I thought, so all good. The slides are available at this URL. If you are interested, just search for GS Waku. There is an NPM package and all the documentation, everything is there. As I mentioned, we are still working on the DappConnect website, so it'll be advertised once it's ready. And we do have some toys to play with. We have the web chat is available at this address here on the GitHub page, and same for SDM, which is end-to-end encrypted message. So feel free to have a go and play around with it and see how it looks. We are hiring, so please feel free to go and check out the GS Waku position there. And we do have a Discord as well if you want to come and chat with us. Any questions? Yeah, so that is awesome question. So there's a few ways to integrate. So on one hand, you can. So it depends how you want to integrate. So if you want to just use Web3 API to do maybe some message signing or something like that, so we're currently working on that on one hand. On the other hand, it'd be interesting to indeed. There's some use cases like the DAO use case. So you have your voting DApp or your DAO DApp, which include voting, and you want to be able to notify your user on the wallet side, so in their wallet, so that they don't have to open the DApp to get notified that the vote has started. So what our target here is to just have DappConnect used by several dApps first, and to see how things goes and really learn from that and get it used. And then once we see that we get adoption, then trying to see what wallets are keen to integrate DappConnect to get the other side of things. Knowing that Status has the Status app is a wallet app as well. So the idea is most likely to also play around with the Status wallet first to showcase this notification and system. So once we reach that, because we have Status wallet, it'd be good actually to also integrate in there once we reach these cases where we want to have maybe wallet notifications or be able to vote directly from your wallet and these kind of features. Okay, so in terms of scalability, so it is an improvement over Whisper, because Whisper was using float sub, meaning that every node was receiving every message. We are using gossip sub. So our relay protocol is just a slight modification of the P2P gossip sub protocol, which as part of the protocol, you have a management of peers. So the idea is that it's trying to keep a healthy number of peers and so that you can limit the number of messages you receive, so there's not too much bandwidth. At the moment, I'm not sure how familiar you are with the P2P, but so at the moment we use one pub subtopic, which means that everyone is basically on the same network, but we have opened the door to maybe shard the network at some point or do some optimization like that on scalability. But in terms of scalability, Waku V1 was already a huge improvement comparing to Whisper, and that's something that I can pass some previous talks that my colleagues talk about. First question. Incentive. Okay, so for the incentive, I haven't yet implemented this protocol. So the protocol is being implemented in Waku as we speak, and I haven't done it in JS Waku. So I'm just going to give you I haven't dig deep into that just yet, but the quick overview is the idea is that as a store node, for example, as a store node, so you save messages from the network, and you can serve them to clients that query you. So you can keep count there. So the idea is to keep count as a store node. And if the balance is such as you always always serving the same client, at some point you ask this client, okay, we need to rebalance the count here. So the idea by rebalancing the count would be to then use the token or use. We're trying to keep things open, but we haven't decided what token we will. This transaction will happen in. But the idea is to be able to then rebalance at this stage. But on the other hand, as we say, it's very modular. So if similarly to the BitTorrent protocol, you could have a situation where everyone participate in a healthy manner to the network, so that everyone can serve. If you serve other clients as well, then this balance is kept in check, and you don't need to pay up. So have a look. I can forward the specs. So if you look for the specs, then it goes in more details. But I'm not there yet in the full understanding, right? So a few things. On one hand, in terms of storing the messages by the store node, we do have a protocol in place as well that helps the store nodes ensure that they have the full image. So in the way that we have a protocol on top of the store protocol, which is our fault tolerant store protocol, which allows store node to ping another store node and just check and say, hey, do I have all the messages that I'm supposed to have in store? And the idea at the moment, the default capacity is 28 days. So just keeping the messages for 28 days. Now, at the moment, as a client, so using JS Waku, so we're still working on discovery, but you're connecting to a number of nodes. And the idea is that it will just pick up any store node that you have, you're connected to. So as a user, you don't have to worry about it. As a Dapp developer, you don't really have to worry about it either. But if you are worried about maybe a store node omitting messages for you, then we can look at strategies. We're not just there yet, but we already have strategies in case a store node maybe miss a message itself and hence doesn't give you a full image. So that's why there is this fault tolerant store protocol as well. Yeah. Yes, so so for now, so for DappConnect, it's just myself, but I'm working very closely with the protocol research team. And so the research team has a number of researchers that are studying these use cases and working on the specs and working on the NIMWAKU, the reference implementation. Again, everything is open source, so we are adopting a system of RFC. So the current RFC is being implemented in NIMWAKU, and we cover like a first functionality of incentivization. And that as we move on, as we get feedback, we can then look into more details into the use cases. But we are working in both the research team and my team. So we already have a number of researchers, and we want to get more people on board to help us with with solving these hard problems that you mentioned. I haven't. I have to double check the research credential at this stage. Sorry, just because I've been working very closely with them, but I started this year, so I'm not exactly. I don't know exactly all their background and everything. But feel free to. I'll definitely drop the question to my colleague and see what they think, and I can tweet about it. Mm-hmm. Mm-hmm. No, it's an excellent point. Yeah, it's an excellent point. And so yeah, because I'm not part of the series, as I mentioned, I haven't dig too deep into this protocol, so I can't really answer your question at this stage. But we do have a number of researchers that are looking into it, and I'll be following up on them so that I know for myself. Awesome. Thank you. Thank you. Okay, so in terms of discovery, currently we don't have discovery. We are implementing a DNS discovery protocol, which is similar to what is used by S2, I believe. So this DNS discovery, we are currently implementing it in Waku in the reference implementation. And once it's in place, then I can do it in JSWaku and be able to answer more precisely. But yeah, so DHT is not yet on the table. But again, the idea is that it's very modular. The idea is to provide a very modular set of protocols. So this DNS. Good question. So I mean, yeah, feel free to come and open an issue on the GitHub and state your case. Something maybe to state is that I try to be very permissive on the design. So for example, when you start a Waku node, when you do this Waku create, it starts a lippy2p node in the background, and you can fine-tune any option you want of the lippy2p. So you have the possibility to pass your lippy2p options to your Waku node. So if you want to do some fine-tuning like that, for example. On the other hand, yeah. So in this case, so I haven't yet reached this stage, but if we are to implement the DHT discovery and we realize that the lippy2p one is not ready and we wanted to have it ready, earlier than lippy2p, then I will do upstream. So I will upstream my work if I need, because I'm using lippy2p a lot because we are basing on that. So there is whatever bugs or issue I encounter with lippy2p, does it make sense? Cool. Awesome. Thank you for the question. All right. Take care, everyone. Thank you. Bye.